Hello everyone, my name is Uday Umbarkar. I am from JD College of Engineering and Management Nagpur from ETC third year department. My topic is role of hyperparameters in deep learning. So here we first discuss what are the hyperparameters. Configurational setting. Hyperparameters are the critical setting chosen before training and control how deep learning models learns and behave. Training controllers. Unlike model parameter, weights and biases, hyperparameters influence the training dynamic architecture and optimization process. Common examples of hyperparameters are learning rate, batch size, number of layers, neurons per layer, dropout layer, and activation function. Let's see why the hyperparameters are matter. First, control the learning behavior. The learning rate, for example, determines how big the weight updates are during the training. Too high, the models may never converge. Too low, it may take the forever time or get stuck. Second, prevent the overfitting and underfitting. Hyperparameters like dropout and regularization strength and network size help to control the how well model generalize to the new data. A large model with no regularization may overfit. A small model too much dropout may underfit. Third, impact on model accuracy. Some hyperparameters directly affect the performance. For example, using the poor optimizer or bad batch size might lead to the worse accuracy even if data architecture are same. Fourth, affect the training time and resource uses. Batch size, learning rate, and model size all affect how fast the model trains, how much the memory it uses, how long it takes to converge. Let us see the key hyperparameters in their effect. Learning rate. Too high, the model overshoots the optimization solution. If the learning rate is too low, painfully shows the conversion. Second parameter is batch size. If the batch size is small, the add the noise but improve the generation. If the batch size is large, speed training but requires the more memory, means more expensive. Third point, architecture parameter. The number of layers and neurons affect the model complexity and ability to capture and integrate the data pattern. Fourth, regularization strength, dropout rates and balance model complexity, preventing the overfitting to the training data. Now let us see how the hyperparameter tuning. There are three types of hyperparameter tuning usually done. There are grid search, random search, and bias optimization. Let's see in detail. Grid search, the exhaustive search over the specified parameter grid, accurate but computationally expensive for the complex model. Random search samples the random combination across the parameter space, more effect for the large and high dimensional search spaces. Bias optimization uses the probabilistic model to guide the intelligent search for the optimal hyperparameter, balancing the exploration and exploitation. Let's see the tools and automation. Popular framework KRAS tuner for the semantic hyperparameter search, Optuna for the advanced bias optimization, built-in libraries in PyTorch and TensorFlow. Automated benefit. These tools track the experiment and compare the results systematically and identify the optimal configuration automatically. Practical example, automatically tuning the dropouts rates to maximize the convolution neural network accuracy on a image classification task. Challenges in hyperparameter tuning. Computational intensity. The deep network with neuron hyperparameter requires the substantial computational resources and time investment. Complex interdependencies. No universal solution and resource trade-off. Best practices. Prioritize the critical parameter. Apply the domain knowledge. Employ the cross-validation technique and documentation for everything. This ensures you the best hyperparameter tuning and gives you the best optimal solution in a low cost. Now we move towards the real world impact and case study. Architecture tuning. Adjusting the convolution layer filters the learning rate and schedules in convolution neural networks delivered significantly accuracy improvement. Optimization impact. Fine tuning batch size and learning rate schedule the enhanced models and generalization on large scale image datasets. Performance reliability. Without proper tuning, our architecture is sound and model consistently underperform or waste the valuable computational resources. Hyperparameter. Hyperparameters are the key to unlock the deep learning potential. Iterative process. The hyperparameter tuning is an experimental driven genre essential for achieving the optimal model performance. Strategic balance. Success requires the carefully balancing the model